Hello, good morning, good afternoon, good evening, whatever time zone you are in. Welcome to our third webinar this particular quarter. Today, we're going to be talking about deep dive into 3.11, which is the upcoming series for AI observability and quality. And joining me today are my esteemed guests. Serena, you want to say hello to the community?
Hi everyone, I'm Serena. I'm a software engineer in Databricks and a core maintainer of MLflow.
Yeah, she has been a regular speaker, so we're always delighted to have Serena over here. Tomo, you want to say hello?
Hi everyone, I'm Tom. I'm also a maintainer of MLflow.
That's right. This is fourth time he's coming here. So these are all regulars, and it was nice to actually have some familiar faces. And soon, shortly, Yuki will be joining us too. He's a bit delayed out there. My name is Jules Damji. I'm part of the developer relations team, and we are coming live to you on 4 different channels, or 3 different channels: YouTube, X, as well as LinkedIn. So if you are joining us from any part of the world, we would actually like to hear you say hello and then tell us where you're hailing, because it's always nice to see people joining this community webinar from different parts of the world. It's always heartening to see all this participation. Okay, today's agenda, quick welcome and introduction. We have already done that. And today we're going to sort of deep dive in some of the upcoming features for 3.11, which is going to be released very shortly. And a few things we're going to talk about today are support for OpenTelemetry. And as you know, OpenTelemetry is gaining a lot of standard for a lot of GenAI applications to create the traces on that. And we will try to figure out what is the semantic way, what are some of these standards that are making it available for us to actually do that. And Yuki is going to talk about that when he joins us. And then we're doing a lot of OpenCode integration that Yuki is going to talk about. And then Serena will jump in to talk about the automatic issue detection, which is really nice to see that we're making the developer experience quite easier by somehow detecting issues early and making your life a lot easier for you. And then those who are stingy and worried about budget, Tomo is going to share with us how to actually use the gateway to somehow create a particular budget. And then we'll answer some Q&A question towards the end, given that the logistics of this particular platform is that we do broadcasting and we release the questions toward the end. Okay, some of things which are actually coming up shortly. In June, the second week of June, we're actually having a global yearly event called Databricks plus AI Summit. This is really an event that actually brings the global community to San Francisco, all of our Databricks customers, along with the large community of open source projects such as MLflow, including Apache Spark, Delta and Iceberg. All these people come together in this global event for about a week. So if you are planning to come, or if you have never been to it, I would advise that you should probably reserve your seat and do join us. And then if you're actually interested in this global roadshow we're actually doing, where we talk about MLflow quite a bit, we'll be coming to your cities nearby. So take a picture of this particular QR code and the bit.ly where you can actually somehow register yourself. So if you are hailing from a city where we're actually coming, do come and join us. And with that, we'd love to hear from you. You can participate quite easily on our Slack channel. We're always there to answer questions, any issues that you actually might have. We do regularly post things on MLflow LinkedIn page where all of our blogs and discussions go. So if you're actually interested to find out what are some of the new things, what are some of the new blogs that are coming up, do follow us on there as well as on X. And then we have a GitHub where you can file issues, where you can actually file PRs. There are a lot of first issues that we are really interested to grow the community. Just last month, we reached our 1,000th contributor for MLflow. So it's actually nice to have so many growing communities, so you can be actually part of it. And I think with that said, I'm going to hand it off to Serena, who's going to talk about automatic agent issues. So Serena, want to take over?
Yeah, thanks, Jules, for the introduction. Now I'm going to start talking about automatic issue detection. That's a core feature that we're going to release in MLflow 3.11. So let's dive in. Let me first start with this picture about how users use MLflow for agent development today. There are 3 key pillars here: tracing, quality evaluation, and monitoring. Tracing helps you understand what the agent is doing step by step. Then comes quality check and improvements, that users need a way to evaluate whether the outputs are correct, useful, or aligned with expectations. And finally, users will use MLflow to monitor agents to ensure the quality doesn't degrade over time in production. Among these, the topic we want to focus today is quality check. This is a core step, since without reliable quality check, then tracing and monitoring cannot give us actionable insights directly. So the key question here becomes, how do we systematically and scalably evaluate quality? So today, how would you check the agent's quality? I think one common approach is manual inspection. You could go through the trace inputs, outputs, and contexts within a session, within some conversations, leave feedback on problematic traces. You might also rely on MLflow dashboard on the right side to track key metrics like latency or error rates. Alternatively, you could also use MLflow Evaluate with built-in or customized judges. In this workflow, you can review the judge outputs to understand whether the quality is acceptable or not. However, all of these approaches have some clear limitations. First, reviewing the traces one by one is extremely time-consuming. As system scales, this quickly becomes infeasible. And second, users often don't even know what metrics to check. Since agent quality is multidimensional, it includes correctness, relevance, hallucination, like every dimensions. So defining the right signal is pretty hard. And third, it's difficult to identify patterns. You might see individual failures, but clustering similar issues or spotting systematic problems is very challenging. And finally, there's usually no structured way to track issues. I think people might use tools like Jira to track issues. However, it's a bit hard to attach all information you have from traces to Jira tickets. So to address these challenges, we built a new feature, MLflow issue detection. The goal is pretty simple. We want to automatically identify quality and operational issues from your agent traces. Instead of manually inspecting traces, we use AI-powered analysis to detect potential issues, categorize them, and surface patterns across traces. This shifts the workflow from manually debugging to automatic, scalable quality analysis. So yeah, for the details, a key part of the workflow is which model to use to power the analysis. We designed this to be pretty flexible, so users can choose what best fits. There are mainly two options. First one is you can use AI gateway endpoints if you've already set it up. And second, you can configure the model from supported providers, including OpenAI, Anthropic, Gemini, and more is coming directly, and specify your API key. We do set up default models for supported providers, but you can also switch it to better trade-off between quality and cost. And yes, cost tracking is supported for all providers. To make the quality check actionable, we need to define what quality actually means. So here we introduce a simple but comprehensive framework called CLEARS, which breaks quality into 6 key dimensions. C is for correctness. This is about factual accuracy. Is the output grounded in the provided data, or is it hallucinating? L for latency. This is about whether a perfect answer is useful if it's not too slow. And E for execution. Did the agent successfully complete its intended actions? For example, tool calls, API steps, or multi-step workflows. Then A for adherence. Does the response follow your instructions and constraints? This includes something like formatting, policies, and system prompts. Then R for relevance. Is the output actually helpful? Does it directly answer the user's question and satisfy the intent? Then finally, S for safety. This is to ensure the response avoids harmful or inappropriate content. So with this framework, CLEARS also gives you a structured way to categorize issues. It makes it much simpler to understand what type of problem you are seeing, and it can aggregate patterns across traces so that you can prioritize fixes based on the category you care. Now, let's walk through how the system works end to end. We start by automatically analyzing selected traces. Based on the chosen categories and model, we detect potential issues directly from the data. Next, we build a deeper session analysis. This combines the model's reasoning, any human feedback you left on the traces, and the actual agent execution steps. And once we have this analysis, we group similar problems together. Using LLM-based labeling and clustering, we can identify recurring patterns across many traces. After clustering, we annotate each trace with its corresponding issue. This includes the reasoning behind it, so you can easily trace why something was flagged by the system. And finally, we generate a high-level summary of the identified issues and their root causes, so you can have a brief summary of the whole workflow. And then we surface each issue as a structured entity, including a few key attributes. First, description, that is a clear explanation of what the issue is about. And severity, that indicates how critical the issue is, so that you can prioritize what to fix first. These two fields can be updated if you are not satisfied with the results. And then comes the number of traces affected by the issue. This tells you whether it's an isolated case or a widespread problem. And of course, category. Based on the categories you selected, you can know whether it's a correctness issue or a latency issue. And we also support issue status tracking. So each trace can be marked as one of 3 status, pending as for newly identified issues that needs your review, and rejected if it's not a real issue, and resolved after you have already addressed the issue and fixed it. This helps you manage issues just like a lightweight tracking system. Besides, we provide issue lineage so that you can navigate from an issue down to individual traces to inspect rationales or vice versa. Yeah, so that's basically the workflow of issue detection. And now let's take a look at a demo. Great. So yeah, here is my experiment that I have tons of traces with my agent called Jarvis. So the entry point is here, this new detect issues button. If we click on it, you can see that upfront, you can select categories. It is the clearest framework we just explained. You can select different categories based on what you want, but here I'm going to just choose everything. Then you can select models. We have 3 providers here, and we have the default model that is adjusted based on the performance. But also you can change the model in the advanced settings here. You can change it, for example, to GPT-5 mini if you want to make it cost less. And then you can select API key here. If you already have some API key, you can just choose it. Otherwise, you can also type your API key directly, and this API key will be saved for reuse. That can be managed in the API keys page here. This API key name is randomly generated, but you can also change it. So this is the workflow that you configure model directly. But if you already have AI gateway enabled, then you can choose the endpoints, of course. After the configuration, we can just choose, here let me choose an existing one. You can just click Run Analysis, and it will start the job. You can view the status, the live status here, including which model was chosen and what categories you just selected. And it will scan the traces you select on your experiment, and it can live updating the issues that have been found. Just to clarify, by default, it chooses all the traces in the current page, but you can also select different traces, for example, on different filters. So my server is a little bit slow now. And while this takes some time to run, I want to show an issue detection result that I have already run previously. So here, I use Gemini 2.5 Pro model and also choose all the categories here. It takes 5.6 minutes to run, and it scanned 472 traces with 13 issues being found. And you can see the total cost here is $0.2. And in this section, we have a brief summary of all the issues we found, including the description, the root causes, and the categories. But here is just a summary markdown, but you can review the detailed issues here. As you can see, we have issues in different stages, and by default, all issues are in pending status because we haven't reviewed them. And all of them are sorted by the severity first, and then the number of traces impacted by this issue. So here, of course, highest issues goes first, and then medium, and finally low issues. For example, if you're not satisfied with the severity, you can change it, or you can change the description after you've investigated this issue. When we click on this issue, you can see all the traces linked to this issue, meaning those traces are impacted by it. For example, if we take a look at this trace, it includes this issue and its rationale. It explains why we marked this issue on this trace and how the latency problem was identified. Here it says the delay occurred within this step that takes 16 seconds. So yeah, it includes the rationale about how we find the issue. So you can review all the traces impacted by this issue and then work on it later. For example, after we've identified this issue and we fix it, then we can change the status to resolve. So we will move this issue to the resolved status, so you don't need to worry again. And another example is, for example, I think this issue doesn't make sense. It's not applicable to my agent. You can just reject this issue, so you won't say it again. After you've reviewed all of these issues, you can improve your agent based on the concrete issues and then do some more analysis. And more features is coming in the next version. Yeah, that's all about my demo. Thanks.
Well, thank you very much, Serena. This is wonderful. I mean, I can see somebody saying, I don't have to do the work; it will just automatically find all the particular issues. I'm sure a lot of questions come up, but I had a lot of questions that I'll end towards the end. Yuki's not here, so Tomo, you actually want to go next?
Yeah, sure.
Okay.
Yeah. So can I start? Okay. Hi, everyone. I'm Tom. Today I'm gonna talk about the gateway budget support feature. So let's start with the motivation. So when you are using language model through APIs, it's very difficult to predict their API cost because there are a lot of factors that influence the cost of language model usage. You might misconfigure prompts. If your prompt becomes bigger, then you will spend more. Maybe like there are increasing number of traffic for your application, and you might have some sort of like a development system, like the CI, that is like recursively calling the language model API and spending a lot of money. So then it's typically teams typically don't have real-time enforcement. So I've seen a lot of like news posts or social media posts that is about the over usage of language model spending. And it's expectable because it's very hard to enforce a real-time spending budget control for LM APIs. Also, if you have multiple teams, or if you are using like multiple LM providers like OpenAI and Anthropic, it's also very difficult to enforce the budget because typically these providers have their own budget control, but there's no like centralized control across multiple providers or teams. Moving on. So let me quickly recap what the ML4 AI Gateway is. So ML4 AI Gateway is a central place to govern and enforce the permission for your language model usage. So you can configure permissions for each provider and model set. You can enable budget control, and you can also use a centralized endpoint for load balancing or enabling the fallbacks for your LM APIs. It comes with a native usage tracking. So whenever you invoke your endpoint, it will create a ML4 trace, and then you can use the ML4 trace for your analysis or for your evaluation later. With ML4 3.11, we introduced a new feature, which is budget control for ML4 AI Gateway. So this is a single enforcement point for your organization, for your team. And if your team is using ML4 Gateway to make a call from an agent to LLM, you can apply budget policy for all the usage from your application or agent. And there's like multiple mode for your budget control. One is alerting. So if you select the alerting mode, you can get notified when the budget is exceeded, basically. And there's another mode which is blocking. You can just consider it as a budget limit or rate limit. So if you select the blocking mode, then your request will be rejected if the budget threshold is exceeded. ML4 Gateway also enables workspace level budget control, which allow you to control your budget or configure your budget per team. And the budget policy is auto resetted for daily or weekly or monthly cycles. So you don't need to configure or reset, the budget policy periodically. The budget is just, reset as a time point that you configured. Okay, let me do the quick demo. Oh, thank you so much for switching. So now this is a UI for ML4 Gateway. We now have another tab, which is budget. Then you can see that, I already have two budget policies. One is the daily policy. This is a little bit too large, just for the demonstration. You can see the current spending. Also, you can see, when the window, like time window start and when the time window ends. Then you can also configure another budget policy like this. I select just like $3 monthly, and I will select a reject mode. Okay, now it's created. Then when I go to, also please notice that this policy is already exceeded. So when you go to their endpoint page and try to call your endpoint, yes, so your request is rejected. Because the budget is already exceeded. So that's how it works. If you want to get alert instead of rejecting the request, you can configure a budget with the alert mode like this. But you also want to ensure that you configure webhook here. So when the budget is exceeded, ML4 will send a webhook notification for the webhook corrector that you configure here. Basically, that's all for the budget policy.
Thank you, Tomo. That's actually good enforcement, because people are really worried about the runaway costs, and having this controls available at the proxy or the gateway is actually a good way to enforce some of the financial limits, especially for startup companies who are experimenting this quite rigorously and aggressively, and not having some sort of a cap limit on finances can really do have hard on the budget. I don't think Yuki is here. I'm assuming we can probably have Serena maybe take the first part of the conversation dealing with the semantic conventions that we are working on. So, Serena, you want to take a stab at it?
Yeah, sounds good. I'm
Thank
going
you,
to
Serena.
take your case part about the upcoming feature for OpenTelemetry GenAI Semantic Convention in MLflow. And a little bit recap about MLflow tracing. So here is the spans details view that we record and visualize the internal steps of your agent with various metadata and latency, including the inputs, outputs, attributes, and events. And also we have this MLflow dashboard that monitors operational health and quality metrics, including number of requests you have in the past several timeline, and latency, errors, token usage, and cost tracking. And of course, the quality metrics like the judges you run on your traces. So what is OpenTelemetry? It is a vendor-neutral open source framework that defines a universal data model for traces, metrics, and logs. It includes the WOW format as OTLP, and it defines what a trace is, and the spans model, including inputs, outputs, attributes. That's the standard OpenTelemetry use. And also, it supports different SDKs and APIs, for example, for Python, because MLflow is Python friendly. And here, MLflow plus OpenTelemetry, we use OpenTelemetry as the underlying data model. So every MLflow span is actually a valid OpenTelemetry span, so that all the traces can be exported via OTLP to any compatible backend like Grafana, Datadog. And also, you can ingest traces from any OpenTelemetry instrumented library. For example, OpenTelemetry and LangGraph. And also, we translate attributes from other OTel compatible clients. That means if you are tracing your agent with non-MLflow clients, you can also ingest the traces into MLflow backend and visualize it on MLflow UI. But the problem is that OpenTelemetry only defines the specs, traces, format, but not the vocabulary. That means a span can actually carry arbitrary attributes, but without a unified name, every tool invents its own name. For example, MLflow uses MLflow.model to represent the model that is used in your trace. And different packages use different names. Then it's a little bit hard if you're using all of them together. That's why the OpenTelemetry come up with this semantic convention for GenAI. It introduced a standardized set of attribute names and types built on top of OpenTelemetry. For example, you can look at the left side. We have GenAI.request.model to represent which model was called. And all of this has becoming an industry standard that different packages are being following. And of course, MLflow also want to adapt that. So this is the new feature that we can generate spans that follow this OpenTelemetry GenAI semantic convention. To enable it is pretty simple. You can just specify this MLflow_enable OTel GenAI SAMCOM to true, and then set up your OpenTelemetry backend endpoint. After that, we can just emit MLflow traces as standard GenAI semantic conventions via OTLP. So how it works is like, for example, MLflow.autolog supports different frameworks, including LangGraph, OpenAI, Anthropic, and it translates those MLflow span attributes into OpenTelemetry attributes. Or you can have other OTel native framework, for example, Microsoft Agent Framework, and they directly emit semantic convention spans. All of them go to the same backend that can understand all of these attributes and visualize them. For example, MLflow, Datadog, Google Cloud, and Databricks. And in the right part, you can see the picture that it visualizes the inputs, outputs as a native MLflow span. That all the functionalities within MLflow traces work pretty well. But yeah, the limitation is that not all frameworks are supported yet. We're supporting gradually, and more will come soon. And also, currently only traces are supported because OpenTelemetry also emits events and metrics in their own semantic conventions, but we haven't supported them yet. But however, all of these trace level attributes and spans are supported. And yeah, the last is that this OpenTelemetry GenAI semantic convention is still under development. If you take a look at their documentation, they're still involving the standards. All of this may change in the future, but we will keep updated with the OpenTelemetry standard. Yeah, I think that's all about the. Oh, hi, Yuki, you're back. Please feel free to take over here.
Oh, wow, welcome, Yuki. How are the waves? I thought you were going surfing. You probably got caught in the waves. But yeah, welcome back. Welcome back. You can probably take over the last bit of the presentation. Thanks a lot, Serena.
Sure, absolutely. First of all, can you hear my voice?
Oh yes, we can, loud and clear.
Okay, cool. Yeah, so sorry, I just mistook the webinar time completely, and thank you so much, Serena, for covering the semantic convention one. And yeah, fortunately, we know all maintainers know like what we are doing. So thank you so much. And yeah, so I'm gonna talk about the OpenCode integration. So this is a kind of one of the new integration we added to tracing. And of course, we are adding a lot to integration. So we have like more than 100 integration. We're using like OpenTelemetry as well. But we're just picking up this one to talk about a little bit about like coding agent integration and why we are investing in this area. Because sometimes we get questions like, hey, why tracing for coding agent? Okay, so first of all, what is OpenCode? I think everyone knows Claude Code. And probably most of people knows Codex from OpenAI. And OpenCode is an open version for it. I mean, Codex is open code, but another open source version of the coding assistant. It is a pretty powerful one, and it's very popular. It has like 130 stars on GitHub, and yeah, it works with any models, so OpenAI, Anthropic, Gemini. And it has a very good build for TUI. In my opinion, it's kind of one of the best TUI across like all coding agent. And from MLflow 3.11, we have OpenCode tracing plugin. So if you install this MLflow/OpenCode plugin from npm using MLflow npm install, and just set up the tracking URI and experiment ID just as usual in environment variable. And OpenCode also support the loading .m file. So if you want to persist this configuration, you can click the .m file, including this to environment variable in your project root. And then whenever you start OpenCode, it will automatically load these settings. And then yeah, you can start OpenCode as usual. And if you type question, if you do a coding, if you do any conversation with OpenCode, that will be logged to as an MLflow trace. And sorry, the page is loading. Oops. Is the page loaded in your screen, Jules?
I can see the tracing open code. Is this a video or is it just a slide?
No, it's just a slide. I think it's not shown in my browser, so I can just open up another window to see my slide.
I can see the supporting coding agent slides, if that's what you mean.
Yeah, let me see. Maybe my Chrome problem. Just a sec. I'm just opening the another window to see my slide.
Yeah, it's okay. I mean, don't worry.
Yep. Sorry, so many troubles, but hopefully.
Yeah, I can see the tracing open code slide now.
Yeah. my guess is my Chrome is super overwhelmed right now. So
Okay, do you want me to then forward the slides for you as you talk? You can just tell me forward the slides.
no, I'm just opening another window. It loads very slowly. That
Okay.
could be
No worries. No worries.
Yeah, probably meantime I can also close some of the sessions. All right.
Probably have too many tabs open, just like everybody else. We seem to have momentarily lost Yuki, but he'll be back. Meanwhile, this is a good time. Actually, if you have any questions, please put them on the Slack and we'll try to address them towards the end. Did we lose Yuki? All right, Sharon, did we lose Yuki?
Yeah, I guess we
Okay.
lost Yuki, but we can continue his slides.
Yeah. Oh, you can continue with the slides?
Yeah, we can try our best. Yeah. So if we trace OpenCode, what's recorded in your trace is like a normal MLflow span on this screenshot. You can see all the conversations, including what tool was called and the reasoning blocks, how many token was used, and of course, latency in this timeline view, and what skill was used. And right now, we have already supported many coding agents, including the most popular Cloud Code, OpenCode, and OpenHands. And as this shows up, we will support it more, including OpenAI CodeX and Gemini soon. But why do we trace for coding agents? So if you just use it for coding, of course, trace is probably not needed. However, it has becoming a general problem solver. We use it daily for code review on our team, of course. We use it for designs, end-to-end tests, content generation, and trading. I personally tried it, but I still need to improve my agent. And in this case, context matters a lot when solving these complex problems. How it resonates all your requests and how it solves those problems. So traces let you inspect and improve the context. It has all the conversations and the execution steps. So once you trace your coding agent, you can debug on it and make improvements. For example, for this skill improvement loop, writing skill is easy. Everybody writes skills, but making it great is different. People might have different questions like, why my coding agent doesn't pick the right skill? Should I put this edge case note in the skill body or reference? And for example, my teammate Tom Wu suggested me to write a different skills test. Is it good or bad? We have all of these questions. So we can use OpenCode tracing to improve this loop. We can define the LM judge for success criteria. For example, this my coding agent only reached this level, then I assume it's perfect. And we can run a few queries with your coding agents, then run the judges on your traces from either MLflow UI or MLflow SDK. We can iterate this loop until all the check pass. For example, in the screenshot, this is a agent eval skill invoked judge we specifically created, and we can use this judge to do sanity check on our traces. And also we can enable optimization. I think there's a blog here. You can check this blog link for more details. But yeah, we can like do some coding to self-improvement the skills. Yeah, I think that's it.
Well, thank you. That was a quick recovery for UK. I'm sure he's going to join us later on. I have a whole bunch of questions that I've been sort of. There he is. Lovely, lovely
Yeah.
UK. Nice to see you back. No worry about it. This is actually a good set of features that you guys actually have developed on top of what we've been doing for 3.8, 3.9, and 3.10, and upcoming in 3.11. Serena, I had a question about. I like the name Clears. It just sends a really good message. But what about if I wanted to have another letter attached to it? How would I go by doing it? Because you have, the clear actually, you have defined what each and every judge associated with. But if I wanted to add another thing to detect the issue, how would I actually go about doing it?
Yeah, that's a great question, and that's also something we're thinking about improving. Because currently this Clears framework somehow defines most the scope that covers most of the situations. But if you want to add more categories later, I think we're going to, for example, support user-specified mappings or categories. But yeah, right now, in the initial stage, that's not supported. But we're open to those feedbacks. Please feel free to file issues on the repo, and we will incorporate those feedback.
And in terms of detecting the issue, I mean, this could be quite subjective, right? So is that fashioned or controlled or dictated by the prompt for that particular judge?
Yeah. Underlying that's kind of implementation details, but yeah, we adjust the prompt based on the categories you choose, and we also have this giant prompt that cares mostly about user feedback, like user experience, whether user feel this conversation is satisfied or not.
Mm-hmm. And then in terms of the severity, you had high, low, and what was it, high, low, and medium, right? Or high, low, and that is something that you actually can detect as part of prompt, that I want the severity levels to be A, B, and C. So that's not something that the judge decides. It's actually part of the prompt, how you're going to evaluate that and what category that you're going to allocate, correct?
Yeah, that's part of how the LLM detect whether this issue is severe or not. And we're also thinking of improving it to include, for example, some rationales about why this is identified as high or low. That is also a next feature.
I mean, this is incredible. You guys have done an incredible job, especially the auto detection issues, because people. I mean, I like one of the scenarios where you actually looked at 453 traces in less than a minute or maybe a couple of minutes, and people, that's a fair amount of traces to go through and evaluate that, and that's quite impressive. Last question for you, Serena. In terms of resolving the issue, does it always has to be a developer, or it has to be a subject matter expert who has the access to go to the UI and resolve that issue?
Yeah, currently this is a UI focused feature. Yeah, but of course, underlying it's MLflow SDK, so we will expose that API later.
And question for you, Tomo. You talked about all the different scoping, the way we actually allocate the budget, and you mentioned something about the per team scoping, and you referred to the workspace. Now, is the notion of workspace something that we introduced in 3.10 with the contributions from Red Hat, or is that something different? It is that particular workspace.
Yeah.
Okay. And so the per workspace, which means that any user in that particular workspace is confined to that particular budget, correct?
Exactly.
Okay. I like that. Yuki, since you're back, I have to ask you a question.
Sorry, my Chrome.
Yeah, it's all right. Time to change to open hands, so never mind. So some user is asking, I think it's user rate DO2, that's a nice name. what parts of these particular features are going to be, okay, well, let's go with that. What would be the simplest justification we could give on using agents to evaluate other agents, in particular on the accuracy of evaluating agents and performing the evaluations? It's a sort of a circular question, but it is an interesting one.
Yeah, I think the biggest kind of the clearest reason is kind of scope. So if you do your agent, if you're building agent here, for example, chatbot for your agent for like automation, there's a scope of your agent, right? So that agent need to answer a lot of user questions, and there's a lot of things that your agent need to meet. For example, the tone of the answer, the accuracy of the answer, if the answer is up to date, or a lot of the criteria. And when you let the LLM, so what you let LLM judge agent do, it's only the sub part of it. So very small part of it where we know the answer something, or where we know the criteria. So does it create that difference? So if you're building agent and you are evaluating your agent on agent, which sounds like a little bit strange at first, but if you look at it, actually that LLM judge is looking at very, very small part of the task. So it breaks down the general task into very small, concrete criteria, and by giving that interaction very, very concrete and very well defined and scope, and sometimes when we give the like ground truth or examples, then judge can do a very great job, and can. So yeah, that's I think the distinction we are using in this eval like framework.
So with open hands, when we're actually writing a judge to evaluate a judge, when you're writing a judge to evaluate an agent, which output is actually code, do you think that particular evaluation is deterministic or is it probabilistic? Because code is something that you can actually execute and say, did it work or didn't work? So it would seem like most of the evaluations for determining coding agents would be less probabilistic and more deterministic. Is that the correct way of phrasing it?
Yeah, absolutely. We still recommend like starting from deterministic one for like like code accuracy, or like is the tool, those criteria can be represented as a deterministic way. And sometimes like agent using LM judge is almost near deterministic with the latest model for small simpler tasks. For example, is this agent called skill? Is this agent called tools? Sometimes we can. It is kind of quicker for us to implement as a judge rather than like writing the parsing logic for trace, and like sometimes like deal with some edge cases. And but yeah, in case if you go to like repeating that evaluation in CI/CD, or if you want to rely on that as a kind of a lot in the system, yeah, I think deterministic approach is usually better.
Right. And so in this case, you would actually have to write a custom judge because you wouldn't have a built-in judge to determine the code. So anytime you're going to be using open hands to create any coding agents, those coding agents are going to create the particular code, and they're going to write the custom agent to actually go ahead and determine the section particular code. Okay, that actually makes sense. And that approach would be similar to, say, Codex and Cloud Code as well, right? Because it's the same. It's the same idea. Brilliant. Question from the crowd here. As usual, is this available in Databricks? This is a lot. So if you were to say what features that we actually, which are upcoming on 3.11, are going to be eventually over a period of time available in Databricks or Databricks Managed Flow?
So yeah, maybe starting from tracing, it's always available. So if
yes,
every year, it logs to your MLflow, your Mind's MLflow. So yeah, it's available. And for issue detection, I think we start experimenting it from OSS side, and once we get more kind of stabilized format, we are thinking moving to reporting as well.
Right. So, I mean, we would consider the auto detection issues currently in open source as experimental, but we do have plans to eventually merge it into the managed so customers can actually use it. Because I can't think of any better tool for me to be able to look at my traces, 500 traces, to look at the issues and automatically give me a classification of severity in terms of low, high, and medium. And also, as Serena pointed out in the demo, exactly tells you where the particular problem is, and also gives the root analysis of that. Which actually begs the question, Serena and Yuki, when you were showing the demo, I saw the little ML assistant icon on the far right hand side. So underneath, is it actually using ML assistant, or is that something just there? Do you know what I mean?
It's a AI icon that's the same as MLflow assistant, right?
Okay.
Yeah,
So it's actually okay. So.
Yeah, it's the same icon, but yeah, we do have plans to integrate this with MLflow Assistant.
And Tomu, in terms of what you talked about, budgets, budgets are an important part of any enterprise organization, whether you're a startup or whether you're an independent self-hosted customer. How much of that is going to be in the AI gateway for Databricks?
Yeah, so we are trying to achieve the feature parity between OSS and the managed. So managed side, Databricks managed gateway also plan to provide the budget policy. So yeah, it's gonna be there in Databricks.
Okay, and do we actually have a timeline, or is this something that we constantly digitally work?
I think I cannot tell the exact timeline, but it's gonna come soon.
Okay. I don't seem to see a lot of questions coming in. I think I had all the. Oh yeah, one question that popped in my mind. Talking about the semantics and the OpenTelemetry. Now, currently, when we do the MLflow tracing, and if I have manual tracing where I have defined the span types, those span types are unique to MLflow. So if I look at the JSON that's actually getting passed around, I see all the common standard that you actually talked about. The start time, the end time, the session ID, and all that. And then there's a dictionary called attributes, right? And those attributes we put in our span type, whether it's a chat model or whether it's a parser or whether it's a LLM call. Is that something that we're planning to make it more standard? Because it seems like this would be something that most people would actually use in terms of, classifying manually what kind of function they've written and what kind of type is that. Is that something that we're planning to do?
Yeah, this is an excellent question. Currently, in the GenAI semantic conversion, we only have very few type of spans. So LLM message and the agent, which is representing the top level root. And also there's a vector search, I think, retrieval span. So we map on the other hand, we have 10, I think, span types built in already.
Yeah.
So yeah, I think it makes sense to actually have a more type of spans in the semantic conversion. We can definitely talk to the council about
yes.
And I also see a lot of other tools, tracing tools, follow the same approach. I saw Langfuse started to add the span type concept in sometime last year. So a lot of tools are kind of converting into the same set of configurations. And yeah, that I think makes sense to have a standard so that users don't need to worry about difference between many tools.
Yeah, because it seems like the attributes JSON that you actually provide part of the entire telemetry JSON, it's there as a dictionary, and if you put it in there, it will appear on the UI. Now, how you actually render it will depend on the subject tool, but there is a dictionary that comes in called attributes, and with that attribute you can just parse that and in our case we specify the different types. I don't have any other questions, but I think that's all I had. Was this something that Yuki, in the last slide, you want to mention about what's coming up in 3.12?
Yep. Sorry, yes. Yeah, I'm sure how much we covered, but yeah, Galileo is coming.
Guardrails! Yeah.
Yeah, I like that. Guardrail it's very good synergy with our evaluation framework because we have all the element judges and all the framework to define evaluation criteria. We also even have like optimization framework for this as well. So super excited for this feature. And model tracing. So yeah, currently if you have images or audio in your chatbot, you can view that on traces. But we are doing a more optimization for how we render multimodal and how we store those data in a way it doesn't like pressure database. And yeah. And next one is a bit more ambitious, but skills registry. I've had a lot of feedback, so the demand about how we manage skill. It is just a markdown with a huge script, but when it comes to you need like 10 or more skills in your organization, if you want to share with your team, share with your users, the versioning becomes a problem. And we also have a plus problem, so we are building the solution for this until up to 3.12. And lastly, user management UI. This is for also the auth feature. So we have like built-in auth for MLflow. Currently, all the user management is done by CLI, but it is much better if you have a clear UI where admin can see all the users and edit access. So that's a kind of a convenient feature, but we are also building until up to 3.11.
Oh, I think that this is brilliant. I mean, I do like the guardrails and I do like the user management. And skill registry is something going to be very similar to prompt registry, where you can actually register the prompt. And in multimodal tracing, if you actually had a RAG that would retrieve an image, we would actually trace that particular aspect of it. Okay. Now, Tomo, is the guardrails in the AI gateway different from the built-in guardrails judges that we actually have? Or are there two different concepts and we shouldn't conflict those?
Yeah, good question. So we are thinking about our data model where guardrail, AI gateway guardrail is a combination of the judge and action. So, the judge, for the judge part, we can use the existing judge framework and the interfaces. So you can bring your, own prompt judge or a code-based judge for the first stage. Then for the later stage, depending on the output of the judge, you can decide on the, rejecting the request, or you can just basically sanitize the request. You can take that kind of action. But for the first stage, yeah, we will definitely integrate with the existing judge framework.
So it's a two-layer thing. You can actually have a built-in judge as a first layer of protection to say, to have some policies. And then the second layer would be on the proxy, on the gateway, where you look at the input or you look at the output, and based on that, you make a particular you take a particular action. Is that a fair way to say it? Okay. Yeah. Okay. Well, I think we are right on the hour. I think this was a good presentation. Nice of Serena, and nice, thanks of Yuki for joining us. And hopefully we'll see you guys back here in 6 weeks for 3.12.